Good evening, dear students. Welcome back. So already you have discussed about the acid basis salts. Okay. So we are going to see the important questions. Okay. We are going to see the MCQs, some competitive level MCQs, fill in the blanks, and some short answers, okay, and long answers. Okay. So before proceeding to the question answer series, okay, so what do you mean by these acids, bases, and salts, students? Yes, what do you mean by the terms acid, bases, and salts? Uh, Already you have studied about this, I hope. Yes. So can anybody tell me how do you distinguish, or how these differ from each other, acid, bases, and salts? Yes, when we talk about acids, okay, so these are very sour in taste, right? Acids, they are sour in taste, right? And the litmus paper, okay, what do you mean by litmus paper? So there are some indicators, okay, there are some indicators which indicates the type of whether the given substance is acid or base. So how it will indicate, okay, depending upon the color change. Okay, it will show the color change. Now, so there is something called as litmus paper. Okay, so there are two types of litmus paper, blue litmus paper and red litmus paper. So acids, what they do, they change the color of blue litmus to red. Okay, so when you have a blue litmus and when it turns to red, it shows that the given substance is acids. Okay, so acids are what? They are sour in taste and it turns the blue litmus to red. What do you mean by bases now? Okay, so bases are bitter in taste. Okay, bases are bitter in taste. And how is the color change shown? It changes the color of red litmus to blue. So when you have a red litmus, it turns into blue. Okay, so indicators. So indicators are used to indicate, okay, whether the given substance is acid, base. Okay, so how it will indicate? By the color change. Okay, so one example is by taking the litmus. So there are two types of litmus paper. Okay, red litmus and blue litmus. So this is the meaning of the word acid and bases. Okay, now litmus, okay, it is a natural indicators. Okay, it is a natural indicator. One more example of indicator is turmeric. Okay, your turmeric can also be a it is a type of natural indicator. So there are some natural indicators also, there are some synthetic indicators also. Synthetic indicators means what? Synthetic indicators means they are made by man. Okay, they are made by man. Okay, now which are the synthetic examples? For example, the methyl orange, okay, phenolphthalein. So these are the indicators which are used to detect acids and bases. Okay, so already in this chapter you have learned about the acids. Okay, distinguish the different definitions of acids, bases. Okay, and the different reactions. Okay, how the acid will react with other substances, how the bases will react with other substances. Okay, so these all things we have already discussed in other classes, right? In the so all the synopsis has been covered with it. Okay, then so coming to the next is the salts. Okay, what do you mean by a salt? Now when acid and base react, okay, when you have a acid and base, it gives you salt and water. Okay, it gives you salt and water, and this salt is a neutral substance. Okay, it is a neutral substance. So how, when you get salt, salt is a product obtained when you do neutralization reaction. Okay, when you do neutralization. So when acid and base reacts, it gives you salt and water. And this type of reaction is called as neutralization reaction. Okay, now the pH of acid, okay, it will be from 1 to 7. Okay, the value less than 7, it is in acids, and the value uh, more than 7, okay, to 14, okay, 7.1, and this is 6.9, okay, it will be acid, and 7.1 to 14, it is your what? It is your base, okay, so it is your base. So 7 is the neutral, okay, 7 is the neutral. So 7 is the neutral pH, okay. So these are the things which are discussed in this chapter. Then what is the importance of pH in our day-to-day life? Okay, so pH is very important in our day-to-day life. Then we have already discussed, we have already discussed about the different types of salts. Okay, the common salt. Okay, common salt is your NaCl. Then you have a sodium hydroxide, NaOH, right? Bleaching powder, baking soda, right? Washing soda. So these are the different salts. Okay, and also you have discussed about their uses in day-to-day life. Okay, so by this brief introduction to the chapter, so let us start with the question series. Okay, so first we are going to discuss the MCQs. Okay, so these are some so these questions, it will be helpful for your uh, different exams, okay, for your NTSC Olympiads exams. Okay, so these are some little high level questions. Okay, so I have taken this question so that it will be very useful for you all. Okay, so let me start. So this is the first question which we are going to discuss. So which of the following is an organic acid? Okay, which of the following is an organic acid? First one, nitric acid. Second one, sulfuric acid. Third one, citric acid. And fourth one is hydrochloric acid. Now, when we have discussed about the acid, okay, there are two types of acid. One is the organic acid, another is the inorganic acid. Organic acid means what? They are naturally. Okay, they are obtained naturally. Inorganic means they are man-made. Now, they have asked among the following four questions. This is given among the following, which is the organic acid. Yes, you can use the chat box to answer your answers. Okay, you can answer there using the chat box. You can answer you can give your answers there. Okay, so which of the following is the uh, organic acid? So when you see nitric acid, what is the formula of nitric acid, student? Nitric acid is HNO3. Okay, nitric acid is HNO3. Sulfuric acid is H2SO4. Okay, hydrochloric acid is HCl. Okay, so these three, okay, these are the man-made acids. Okay, these are not naturally available. But citric acid, okay, the answer is citric acid. So citric acid is the organic acid, and this organic acid, it is where you can see the citric acid in the fruits. Okay, in the fruits like your oranges, right? In the oranges, lemon. Okay, what it consists of? It consists of citric acid. So this is naturally available. Okay, this is a naturally available acid. So it is what it is called. It is the citric acid. Okay, so this is the organic acid, example of organic acid. Okay, I hope this is understood. Okay, next one. If carbon dioxide gas is passed to the solution A, okay, if carbon dioxide gas is passed to the solution A, it turns milky. Okay, it turns milky. Milky means what? It will turn like a milk color. Okay, like white color. Okay, milky means it will turn like milk color. Okay, white color. Then the nature of the solution A is. So what will be the nature of the solution A? First one acidic, second one basic, third one neutral, and fourth was amphoteric. Okay, what do you mean by acidic? Acidic means what? The pH will be less than 7. Basic means their pH will be more than 7. Okay, neutral means, okay, it is a neutral, nor acidic, nor what? Nor acidic, nor basic. Amphoteric means what? What do you mean by amphoteric, students? Anybody? Amphoteric means, okay, so these are the substances which acts, okay, which will able to react with both. They will attack with both acid as well as base. Okay. Okay, they will react with both acid as well as the base. Okay, can you tell me if carbon dioxide gas is passed to the solution A? Okay, if the carbon dioxide gas is passed to the solution A, it turns milky. Then the nature of the solution A is, what will be the nature of the solution A? If carbon dioxide gas is passed through the solution A, it turns milky. Then the nature of the solution A is. It will be basic. Okay, it will be basic in nature. Carbon dioxide, okay, it is a gas. Okay, it is a gas. When you pass to a solution A, okay, when you pass through a solution A, it will turn milky. Okay, now what will be the nature? It will be basic in nature. Okay, next one. Vitamin C is one form of. Vitamin C is one form of. First one, formic acid. Two, ascorbic acid. Three, tartaric acid. And four, oxalic acid. So what is the form of the vitamin C? Yes. Yes, vitamin C is one form of vitamin C. Okay, vitamin C consists of what? Vitamin C. It is a ascorbic acid. Okay, vitamin, it is what? Ascorbic acid. So where this vitamin C is useful, okay, it helps to protect the cells, okay, vitamin C, okay, that is how to take vitamin C by sun rays, okay, by eating oranges, right? Then carrots, right? Citrus fruits, right? So from that you can obtain the vitamin C. So what it will help? Vitamin C, it will help to maintain your skin, okay, your blood vessels, bone, okay. So ascorbic acid. So vitamin C is nothing but it is the ascorbic acid. So option number 2. Okay, vitamin C is one form of ascorbic acid. Okay, next one. Aqueous, aqueous solution of an acid is a good conductor of electricity due to the presence of 1. Free neutrons, 2. Free atoms, 3rd. Free ions, 4th. Free molecules. Aqueous solution of an acid, okay, is a good conductor of electricity due to the presence of. Yes, it is due to the presence of free ions. Okay, acid. Acid means suppose I take HCl. So HCl, when it's split, when you add in water, it will split into H plus and Cl minus ions, right? So it is why it is a good conductor of electricity, because free ions. Okay, there are free ions. Okay, free ions are available. So because of this free ions, H plus and Cl minus ion, okay, you can see that it is a good conductor of electricity. Okay, so acid, like example H2SO4, when it undergoes, when you add in water, when you add in water, it will dissociate into H plus and Cl minus. Okay. Okay. So it is because of this free ions, it is a good conductor of electricity. Okay. Next one. Stearic acid is present in. Stearic. Okay. Stearic acid is present in. First one uric, second one fats, third one apple, and fourth one curd. So stearic acid, it is present where? Stearic acid. Stearic acid is present in. Yes, students. Apple. What does apple consist of? So when you talk about first stearic acid, okay, stearic acid is what? It is the saturated fatty acid. Okay, it is a saturated fatty acid. So it also called as the octadecanoic acid. Octadecanoic acid. Okay, so it is like waxy. It is like wax. It has waxy solid. It is a waxy solid. Okay, and this consists of what? It is present, as we say, stearic acid is what? It is a saturated fatty acid. So it is present in fats. Okay, it is present in fats. So stearic acid, it is present in fats. Okay, stearic acid is present where? It is present in fats. So it is a saturated fatty acid. Okay, saturated fatty acid, which is also called as octadecanoic acid. Okay. Urine, okay, urine consists of which acid? Urine consists of uric acid. Okay, curd consists of lactic acid. Okay, curd consists of lactic acid. Then your apple. Apple consists of which acid? It consists of malic acid. Okay, it consists of malic acid. So fats consist of stearic acid. Okay, so our answer is what? Our answer is second one. Okay. Okay, let us go for the next one. An acid reacts with crushed eggshells to give a gas that turns lime water milky. The eggshell contain. An acid reacts with the, suppose I take a acid, okay, and I react with the crushed eggshells. Okay, the eggshells, crushed eggshells. Okay, to give a gas. Okay, it will give a gas. This gas, what it will do? It will turn lime water. Okay, it is turning lime water milky. It is turning what? Lime water milky. So what does this eggshell consist of? What does this eggshell consist of? Yes, students. When does lime water turns milky? An acid reacts with crushed eggshells to give a gas that turns lime water milky. The eggshell contains. So the eggshells, okay, the eggshells are made up of what? They are made up of calcium carbonate. Okay, the eggshells, remember that they are made up of calcium carbonate. Okay, and the gas. So the gas which is released, okay, when the acid reacts with calcium carbonate is the carbon dioxide gas, and this will turn the. Okay, so acid, when it reacts with the eggshells, which consist of calcium carbonate, which is made up of calcium carbonate, okay, it releases carbon dioxide gas. This carbon dioxide gas, when is passed in the lime water, it turns lime water milky. Okay, so the eggshell consists of what? It consists of calcium carbonate. Okay, calcium carbonate. Understood? I hope these questions are clear. Okay, so we have seen 6 questions. Okay, we have seen 6 questions. Okay, let me go for the next one. Which one of the following is not an alkali? What do you mean by alkali? Alkali. What do you mean by alkali, students? Which of the following is not an alkali, they have asked. Yes. What do you mean by alkali? So remember that alkali is what? Okay, it can dissolve in water. Okay, it can dissolve in water. Alkali is a substance which can dissolve in water. Okay, and it will combine with acid to form salts. Okay, it will combine with acid to form salts, and they will make the acids less acidic. Okay, this alkalis, they are having bitter taste. They are having what? They are having bitter taste. Okay. So, best example of alkali is what? Sodium hydroxide. So, sodium hydroxide is a best alkali. Now, they have asked which among the following is not an alkali. So, sodium hydroxide is a alkali. Which is not a alkali? Calcium hydroxide is also a alkali. Okay, so this is also alkali. Potassium hydroxide is also alkali. Calcium hydroxide is also alkali. Your this cupric hydroxide, okay, CuOH twice, okay, CuOH twice. So CuOH twice is not an alkali. Okay, so your copper hydroxide. So your copper hydroxide is not an alkali. Okay, because alkali, it should be soluble in water. So your NaOH, KOH, and calcium hydroxide, when you add in water, they will dissolve. But copper hydroxide, when you add copper hydroxide to water, it will not dissolve. Okay, fine. Go for the next question. Which of the following is not a property of bases? Which of the following is not a property of bases? First one, they have a sour taste. Second one, they have corrosive action. Third one, they are good electrolytes. Fourth one, they are soapy to touch. Which is not a property of base? Property of bases. So when we discuss the property of bases, okay, the first property is the taste. So how is the taste? Bases, they have bitter taste. Okay, they have bitter taste. Okay, then when you feel, okay, when you touch them, they are soapy to touch. Okay, they are soapy to touch. When you, how is the appearance or how is the feel? Okay, it is soapy to touch. And what is the color change? It will change the red litmus blue. Okay, it will change the red litmus blue. So these are some of the properties. Okay, bases, they will conduct electricity. Okay, they will conduct electricity. What is the pH? They conduct electricity. Okay, so I hope you are noting down this points. Then the pH of the basis is from 8 to 14. Okay, the value for basis is 8 to 14. Okay, so these are some of the main important, what you can say, properties. Now here they have given 4 options. So they have asked which is not the property. Okay, now when we tell about taste, it is bitter in taste, and they have given what? They are given sour in taste. Sour property, it is of your acids. Okay, so this is not the property of bases. They are having bitter taste and not sour taste. Okay, rest of the other uh, properties are correct. Okay, rest other properties are correct of your. Okay, so okay, so rest of there are the properties of the basis. Okay, and this is not the correct property of basis. Okay, first one. Fine. Let us go for the next one. Metal carbonate on heating gives metal carbonate on heating gives its oxide, which turn the litmus solution blue, showing that the nature of the oxide is first one acidic, second one basic, fourth one neutral, and fourth one amphoteric. Metal carbonates. Okay, metal carbonates on heating gives its oxide, which turns the litmus solution blue, showing that the nature of oxide is. So what will be the nature of oxide? First one acidic, second one basic, third one neutral, fourth one amphoteric. Yes, students, try to answer. Yes. Fantastic calcium carbonate. Okay, when you heat calcium carbonate, it will give you calcium hydroxide plus carbon dioxide gas. So what they have asked, when it gives this oxide, it will turn the litmus blue. Okay, when it turns the litmus solution blue, showing that the nature of the, when it turns blue, okay, what it means when it turns blue? It means it is basic in nature. Okay, it is basic in nature. So I have taken one example. If I take a metal carbonate like calcium carbonate, okay, when you heat it, you're going to get a calcium oxide. And this calcium oxide, okay, it will turn the litmus solution blue. That means the nature will be basic. Okay, it is basic in nature. Okay, so it will turn your red litmus blue. So when you turn red litmus blue, then it is basic in nature. Okay, let us go for the next one, 10th one. Generally, the nature of a non-metal oxide is. So what is the nature of a non-metal oxide? First one acidic, second one basic, third one neutral, and fourth one amphoteric. Now you know the meaning of this acidic, basic, neutral, and amphoteric, right? So how is the nature of a non-metal oxide? They are generally what? They are generally non-metal oxides. They are how? They are acidic in nature. Okay, they are acidic in nature. So non-metal oxides, they are, for example, if I take a non-metal oxide like your carbon dioxide. Okay, so how you get this non-metal oxide? When you are non-metal, calcium is a non-metal. When it reacts with the oxygen gas, okay, you are going to get a carbon dioxide, right? This carbon dioxide is what? It is acidic in nature, okay? And it is a non-metallic oxide. So option number one, okay? One is the correct answer. Okay, let us go for the next one. Neutralization is first one an exothermic process, second one an endothermic process, third one a reversible process, fourth one an equilibrium process. Neutralization is. What do you mean by neutralization? I give you example. When acid reacts with base, it will give you salt and water. Okay, and these reactions are called as the neutralization. So can you tell me what type of reaction it is giving you? Exothermic, endothermic, reversible, and equilibrium. Yes. Neutralization is exothermic, endothermic, reversible process, or an equilibrium process. Yes. Do you know what do you mean by exothermic? Exothermic reaction means what? It releases heat. Okay. It releases heat. Exothermic reactions are those reactions, okay, where heat is released. Okay. Then endothermic means what? Heat is absorbed. Okay. Heat is absorbed in the your endothermic. Then reversible means what? That at any what you said, at any time you can reverse the direction. Okay, you can reverse the direction, okay, of the process. Okay, so it is a reversible. Equilibrium means what? Equilibrium means like this, okay, at equilibrium. So equilibrium means, so suppose A plus B giving you C plus D. So an equilibrium will be existed, okay. So at equal proportion, the reactants are converted into products and products are can be converted back to reactant. Okay, so when you see a neutralization reaction, that is when your acid reacts with base to give you salt and water. Okay, so it is a exothermic reaction. Why it is a exothermic reaction? Because it that time your heat is released. Okay, when a neutralization reaction occurs, what happens? Heat is released. Okay, released. Heat is released. Okay, so it is a neutralization reaction. Okay, which of the following solutions conduct electricity? Which of the following solution conducts electricity? First one, urea solution. Second one, sodium hydroxide solution. Third one, glucose solution. And fourth one, all of this. Which of the following will it will conduct electricity? Urea, urea solution, sodium hydroxide solution, glucose solution, and all of this. This is your urea. So when you add urea in water, okay, they will not give you any ions. Okay, urea, when you add it in water, okay, so urea, when you add it in water, it will not release any ions. Now, sodium hydroxide. Okay, sodium hydroxide, when you add in water, it will split into Na plus, okay, and OH minus, and this water, okay, that is H plus and OH minus, like this. Okay, so ions are there. So when free ions are present, what will happen? It will conduct electricity, right? Remember, when free ions are responsible for conduction of electricity. Okay, so because of that, it is a good conductor. Okay, so the answer is your this. Okay, it is a electrolyte. So your glucose solution. So glucose is what? Whether it is a electrolyte or non-electrolyte, glucose is a electrolyte or non-electrolyte, student. It is a non-electrolyte, right? It is not, it is a non-electrolyte. Non-electrolyte means what? When you add it in water, okay, it will dissolve, but it will not dissociate, okay, inside the solution into ions. It will not dissociate into its ions. So it is considered as non-electrolyte. Urea is also a non-electrolyte. Sodium hydroxide is a electrolyte because when you add it in water, it will readily dissolve with the and it dissociates the free ions also, okay, and it dissociates free ions also. Okay, fine. Let us go for the next one. So I hope it is clear. So our answer is second one. Next one, antacid tablets usually contains. So what does antacid tablets contains? Antacid tablets usually contains. So antacid, okay, it usually consists of your calcium, magnesium, and aluminum. Okay, as the active ingredients. Okay, it will be present in the form of the salts. Okay, it will be present in the form of the salt. Okay, so magnesium hydroxide. So magnesium hydroxide. So answer is magnesium hydroxide. So antacid usually contains the magnesium hydroxide. Okay, let us go for the next one. Which one of the following acid is present in the stings of ant or bees? Which of the acid is present in sting of ants or bees? Methanoic acid, formic acid, both 1 and 2, and none of this. Yes, which of the acid is present? Okay, so formic acid and methanoic acid. Okay, both the names are same. Formic acid and methanoic acid. Formic acid is only called as the methanoic acid. That is HCOOH. Right. So this is the formula of your methanoic acid or formic acid. So the answer is third one. Both 1 and 2. Okay. So the sting of ants or bees consist of methanoic acid. Okay. And the formic acid. So both 1 and 2 are the correct answers. Okay. Let us go for the next one. The addition of base in water. Addition of base in water. First one increases the H plus ion concentration in water. Second one decreases the pH value of the solution. Third one increases the pH value of the solution. Fourth one decreases the number of OH minus ions in the solution. The addition of base in water increases the H plus ion concentration in water, decreases the pH value of the solution. Third one increases the pH value of the solution. Fourth one decreases the number of OH minus ions in the solution. What will happen when you do the addition of base in water? Yes, when you add base in water, okay, what will happen to the pH? The pH will go on increasing. Okay, pH will go on increasing. So option number third one. Option number third one. Okay, so what will happen to the pH? pH will go on increasing. Okay, because OH ions will be more, right? The number of OH ions will be more. So what will happen to the pH? The pH will be more than 7. Okay, that is, it will be more than 7. That okay. So pH will go on increasing. Okay. What is the range of pH in human body? What is the range of pH in human body? So how much it should be the human pH? It should be 7 to 7.8. Okay, nor acidic nor basic. Okay, so in neutral pH. So the range of the pH in human body is 7 to 7.8. Okay, nor acidic nor basic. So it should be 7 to 7.8. Okay, remember that. So the range of pH in human body is 7 to 7.8. Okay, next one. Which of the following salts have pH less than 7 value? Okay, first one Na2CO3, second one aluminum chloride, third one NaCl, fourth one ammonium carbonate. So which of the following salts have pH less than 7 value? Yes, which is having the pH less than 7 value, students? Which of the following salts have pH less than 7 value? Sodium carbonate, aluminum chloride, sodium chloride, or ammonium carbonate? Yes. So the answer is third one. Okay. So when you add aluminum chloride in water, okay, it will give you what? Aluminum hydroxide. Okay, it will give you aluminum hydroxide plus HCl. Okay, this aluminum hydroxide is what? It is a weak base. Okay, it is a weak base, and we know that HCl is a strong acid. Okay, it is a strong acid. So as the influence of the acid will be more, right, as compared to that of Al, that is because AlCl3 is a more acidic in nature. Okay, because the influence of HCl will be more because AlCl3 is what? It is acidic in nature. So what will happen to the pH? pH will be less than 7. Okay, why? Because when you add aluminum chloride in water, okay, it forms aluminum hydroxide. But HCl, as it is a strong acid, the influence will be more, and we know that when you have more acid, the pH acids are there, the pH will be less than 7. Okay, so option number second one. And when you have sodium carbonate in water, okay, it will give you NaOH plus H2CO3. Okay, so here carbonic acid is a weak acid and NaOH is a strong base. So pH will be more than 7. Then NaCl, when you add in water, okay, you are going to get what? NaOH plus HCl. Okay, so NaOH is a strong base, okay, and HCl is a strong acid. So what will happen? Both will neutralize each other, okay, and so what will happen? The pH will be nearly equal to 7. So it will be not less or more than 7, it will be nearly equal to 7. Now ammonium carbonate, okay, when you add in water, it will give you ammonium hydroxide plus carbonic acid. Okay, so your ammonium hydroxide is a weak base. Ammonium hydroxide is a weak base. Okay, and your this is a weak acid. It is a weak acid. So what will happen? The ammonium carbonate, okay, it is basic in nature, and what will happen to the pH? pH will be more. Okay, more than 7. So which is our answer? It is second one, aluminum chloride. Understood? Is it clear up to here? Okay. Let us go for the next question. The type of salt which completely ionizes in aqueous state is. The type of salt which completely ionizes in aqueous state is. First one, salt of strong acid and weak base. Second one, salt of strong base and weak acid. Third one, salt of strong base and strong acid. Fourth one, both 1 and 2. The type of salt which completely ionizes in aqueous state is. Yes. So when you have a strong acid and strong base, okay, when you have a strong acid and strong base, the salt, okay, it will be completely neutralized. Okay, it will be completely, it will ionize. So it is option number 3. Okay, option number 3. So, salt, so when you have a strong base and strong acid, the salt which is produced, okay, when you add it in water, it will completely get ionized. Okay. Next one, what is the chemical name of washing soda? First one, sodium bicarbonate decahydrate. Second one, sodium carbonate decahydrate. Third one, sodium carbonate tenhydrate. Fourth one, sodium carbonate hexahydrate. So what is the chemical name of washing soda? What is the chemical name of washing soda, students? Chemical name of washing soda? Na2CO3 dot 10H2O. Okay, decahydrate. So sodium carbonate decahydrate. Second one, sodium carbonate decahydrate is the chemical name of washing soda. Okay, okay. Okay. Next one. By which process sodium hydroxide is prepared? By which process sodium hydroxide is prepared? First one, dehydration of NaCl solution. Second one, electrolysis of aqueous NaCl solution. Fourth one, chlor-alkali process. And fourth one, both the 2 and 3. So you can prepare the sodium hydroxide, okay, by both electrolysis of aqueous NaCl solution, NaCl, or it is called as the brine solution. Okay, you are going to subject it to electrolysis. You are going to pass electric current, okay, through the brine solution. And second, next is the chlor-alkali process. Okay, chlor-alkali process. So by both this process, you can prepare the sodium hydroxide. Okay, next question. Number of water molecule present in gypsum as water of crystallization is. First one 2, second one 4, third one 6, and fourth one 8. So how many number of water molecules are present in gypsum? Yes, students. Gypsum. Okay, gypsum is nothing but calcium sulfate dot dihydrate. Okay, so it is associated with two water molecules. Okay, it is associated with two water molecules. Is it clear up to here? So these are some 21 questions which we have discussed. Okay, from the chapter acid, bases, and uh, salts. Okay, so I hope all the questions are clear, right? So let us go for the fill in the blanks. So fill in the blanks. Solution with pH 7 is dash in nature. Yes, what will be the answer, students? Solution with pH 7, it will be a dash in nature. Solution with pH 7 is dash in nature. Yes, we know that. 1 to 6.9, it is acidic in nature. Right, then 7.1 to 14, it is basic in nature. And 7 is neutral in nature. So it is neutral. So the pH 7 is what? It is neutral in nature. So less than 7, remember it is acidic, and more than 7, it is basic. Okay, next question. The acid found in dairy products is, which is the acid present in dairy product? It is the lactic acid. It is which? It is the lactic acid. So lactic acid is a natural organic acid. Okay. It is used for fermentation, lactose fermentation. Right. So it is present in what? It is present in your milk. Okay. Fine. Next one. The gas formed when an acid reacts with a metal is. So which is the gas which is formed when an acid reacts with metal. Okay, suppose I take Na, okay, as a metal, and it is reacted with an acid. Okay, 2Na plus gives you, okay, gives you what? 2NaCl plus H2 gas. So what is the gas liberated? It is the hydrogen gas. It is the hydrogen gas. So when a metal reacts, okay, with the acid, okay, so which gas is released? It is the hydrogen gas. Okay, it is a hydrogen gas. Next question. The reaction between an acid and base is called as what? It is called as the neutralization reaction. It is called as neutralization reaction. Neutralization reaction. Okay. Are these four questions clear? So four fill in the blanks. So solution with pH 7, it is neutral in nature. The acid found in dairy product is what? It is a lactic acid. Third one, the gas formed when an acid reacts with a metal, it is the hydrogen gas. Fourth one, the reaction between an acid and a base, it is called as a neutralization reaction. Okay. Next questions. The acid found in vinegar is. So which is the acid present in vinegar? Acid present in vinegar is, it is the acetic acid. Okay, remember that it is the acetic acid. So acetic acid is present in the vinegar. The ion responsible for basic nature of NaOH is. The ion responsible for basic nature of NaOH is. Yes, NaOH, when it is added in water, it will split into, it will dissociate into Na plus and OH minus. So the basic nature, it is due to the OH ions. Okay, it is due to the OH ion, that, or you can say as hydroxide ions. Okay, hydroxide ions. Fine. The acid found in lemon is, so which is the acid found in lemon, students? Which is the acid found in lemon? It is the citric acid. Okay, it is the citric acid. Next question. The gas found when an acid reacts with a carbonate is. The gas formed, the gas formed when an acid reacts with a carbonate is. So acid, when it reacts with carbonate, okay, carbonates, okay, what you are going to get? You are going to get a carbon dioxide gas, okay, CO2 gas. CO2 gas is obtained. Fine. Next one, dash reacts with an acid to form a salt, water, and carbon dioxide. Dash reacts with an acid to form a salt, water, and carbon dioxide gas. So when you have a metal carbonate, okay, when you have a metal carbonate, so when metal carbonate reacts with an acid, it gives you a salt, it gives you water and carbon dioxide gas. When rainwater mixes with SO2, when rainwater mixes with SO2, gas present in the atmosphere causes, what it causes? It causes acid rain. It causes acid rain. Okay. So these are the answers. So when rainwater, it mixes with the sulfur dioxide gas, which is present in the atmosphere, what it causes? It causes acid rains. Okay, I hope these questions are clear. Okay, very simple questions. Okay, but very uh, you need to know the answer properly. Okay, so so I have taken, so in today's session we have discussed the MCQs as well as the fill in the blanks. So we have some short answer type questions and that is very short type, and some short type questions and long type questions. So these questions we'll be discussing in the next slides. I hope today's session is clear. Okay, so we have taken some MCQs and fill in the blanks, right? So the rest part I'll be discussing in the next class. So any doubts up to here? Any doubts up to here? So if you have any doubts, you can ask me. Yes, any doubts? If you have any doubts, you can ask. Okay. So I shall end this session here. So the remaining part we'll be discussing on the Saturday. Okay, Saturday I'll be continuing with the same. So the remaining questions, short questions, okay, very short questions and the long type questions. So we'll be discussing in the Saturday's class. I hope today's session is clear. Okay, so thank you, dear students. So I'll be ending this session here.